Okay, in the last lecture, we studied up to a point where we were discussing the different levels of service, and the levels of service are dependent upon the value of density. And we are talking about uninterrupted flow facilities, which include basic freeways and multi-lane highways. And we will continue on other parts of the freeway as well. So, so the important points were the capacity is in terms of 15 minutes flow rate. It is taken in terms of passenger cars per hour. Okay, and then these are the values for density on the basis of which you can define the level of service. And A means completely free flow, then B is stable under free flow, then C means that the speeds are reducing, D is approaching the unstable condition. Up till now the flow is sustainable or stable. Then E is capacity, because the flow is now approaching the E is capacity and the flow is unstable, because then people need to make allowance for other drivers to change their lanes or do something like this. So that makes the flow unstable. And then for F, we know that F means that it is level of service F is breakdown. Okay, the reason why we discuss the freeways and basic freeways and multi-lane highways together is the methodology which is given in the highway capacity manual, which follows the same steps. So first of all, you need the input data about geometry, demand, and free flow speed. Then if the free flow speed is already measured from the field and there are no adjustments required, then you're going to skip step number 2. Okay, but otherwise you have to do step number 2 as well. So step number 1, you need the data about road geometry, number of lanes, lane width, basically the data about the cross section of the road. Then you need the demand volume and the free flow speed. If you don't have the free flow speed, you did not measure it, then we will discuss how to calculate it as well, and then it may need some adjustments. Then calculate the capacity and adjust the capacity. Then you should have the demand volume from the field or from your prediction, and then you apply the adjustment factors in that as well. And then after these adjustments, you will calculate speed and density, and the density will eventually lead you to level of service. Okay, so the geometric conditions have some base values, ideal values. These geometric conditions, as I mentioned, they are referring to the mainly the cross section of the road, but there are some other things included as well. So we have lane width, lane width standard is 12 feet, but it can be more as well. It will still be considered standard or ideal. Letter clearance is 6 feet on the right hand side and 2 feet on the shoulder side. Again, minimum values. Then we have ramp density. What is ramp density? It's the number of ramps divided by distance. How much distance? So this is fixed here. So if you are doing the analysis in one segment, then from that segment you go 3 miles forward, which we call as downstream, and 3 miles backward, which we call as upstream. And within these 6 miles, you can count the number of ramps you have. Then this number divided by 6 will give you ramp density. Terrain, we have a maximum value of 2%. So 2% or less is considered ideal. Driver population, the ideal thing is that drivers are regular drivers. For these regular drivers, the other term is commuters, which they are using here. Weather, we need clear weather, good visibility. So clear weather, basically the ideal weather conditions are those which do not have any problem with visibility due to fog or rain or snow or glare or any reason. Then we have incidents. So the ideal condition here is we should not have any incidents, and these incidents may refer to a vehicle breaking down, a crash, police activity, protocol, anything like this. Work zones mean construction activity on the road or on the side of the road, and ideal condition is that you should not have any work zones. So free flow speed is the first thing, or one of the things you have to measure in the initial step. So you can measure free flow speed for passenger cars. No heavy vehicles should be involved, and it can be measured when the flow conditions are low. What do we consider as low? Less than 1,000 passenger cars per hour per lane is considered as a low flow condition. And remember that we are talking about uninterrupted flow facilities. So in the cases of these facilities, then less than 1,000 vehicles, passenger cars per hour per lane is considered as low Then you see two equations on the slide here. The first one is for the free flow speed of freeways. The second one is for multi-lane highways. So in the first one you see base free flow speed, BFFS. In most of the books you will find the value of BFFS to be 75.4 miles per hour. So we will use it here as well. Then you see the factor for lane width, factor for right hand side lateral clearance, FRLC. So we just need the right hand side lateral clearance here, and keep in mind the shoulder is included. Shoulder is part of lateral clearance. And then we have total ram density, which I have explained earlier. In the equation of multi-lane highway, the second equation, we again have base free flow speed, the lane width adjustment factor. For multi-lane highways, we take adjustment factor for total lateral clearance. So the lateral clearance on the right hand side as well as on the left hand side, both will affect the free flow speed. Then we have the factor for median type and the factor for access point density. Now you don't see these factors or something related to them in the multi-lane highways, in the freeways equation, the first equation. The reason is that freeways always have a median, so there is no other condition here, and freeways don't have access points at all. So that's why we don't need these factors in the freeway equation. Let us look at the values of the factors. So the first table you see is for the factor of lane width. So as we mentioned earlier, that 12 feet is considered as the ideal, so you can see the factor becomes 0, and then so on and so forth. Less than 10 feet, then it will be very difficult to make it for an uninterrupted flow facility. So that's why you don't see a value less than 10 feet here. And more than 12 feet, the factor will remain 0. Then the factor for right hand side lateral clearance, 6 feet is ideal value, so anything 6 or more than that has a factor of 0. And for anything less than that, then we have a factor, and that factor depends upon number of lanes in one direction. Then we have factor for median type. We have undivided. We have two-way left turn lane, which is an extra lane between the two directions for turning left. I have discussed it in the traffic engineering course as well. I showed you a video as well. And then we have the divided multi-lane highway, which means is the median. Then we have factor for access point density. This factor, first of all, access point means an point from where you can enter the highway from a driveway. Okay, so it's not from another street, and that point is unsignalized. So the highway, the multi-lane highway, has a priority of movement always. So multi-lane highways can have these points, and their density is, you have to count the number of points you have divided by the distance. The distance is segment length, so there's no 6 mile or 3 mile here. And between the values which are given in the table, you can do interpolation, there's no problem. Then we have the factor for total lateral clearance. So total means right plus left. So if you have 4 feet on the right hand side, 3 feet on the left hand side, then the total is 7. So in this table, you will use the lateral clearance 7. Another thing which you have to keep in mind, that whenever we don't have a median, so median is anything which is between the two directions, anything. It can be a lane, an extra lane, like I explained earlier. It can be just marking, just an empty space between the two directions. It can be a curb, it can be a barrier, anything which separates the two directions then becomes a median. So on undivided highways, there is no separation. So the actual lateral clearance on the right hand side, the median side, so median side means the left hand side. So the actual lateral clearance on the left hand side, the median side, is 0. But the problem is, for undivided highway, we already incorporated a factor here. Okay, so we cannot put two factors, the effect of the one condition, which is undividedness of the highway, on two factors. So we already have the impact of the highway being undivided on median type factor. So you want to avoid duplicating this effect. So what we will do, on the left hand side, we'll take the value of the lateral clearance to be 6 feet, which is ideal, the base condition, as I showed earlier. So for example, you have undivided highway. The right hand side lateral clearance is 4 feet. It's undivided, so there's nothing on the left hand side. But according to this approach, we'll take the left hand side to be 6. So total will be 4 plus 6, 10. Okay, so whenever the highway is undivided, the left hand side lateral clearance becomes 6 feet, and then it is added to the right hand side for the factor. And the reason is to avoid duplication of the effect of the highway being undivided. That effect is already incorporated in the factor of the median type. Let us look at an example here. So we have a 4-lane freeway, and 4-lane means that they have given us a total number of lanes. Okay, and then it's an urban area. It has only 11 feet lane width, 2 feet lateral clearance. Obviously it's a freeway, so we know we only need it on the right hand side. It has a 6-mile section, 6 miles forward backward, and this section has 7 interchanges and 16 ramps. So interchanges are points from where you can actually cross this highway from top of it or from the bottom, like on a bridge or in the tunnel, or maybe the highway itself, the freeway itself is on a bridge and you're going on the ground level. So all these points where the two highways are intersecting at different levels are called interchanges. Some of the interchanges may have a ramp, and some may not have a ramp. And some interchanges may have more than one ramp, one for coming in, one for going out, and so on and so forth. So that's why number of interchanges and ramps can be different. But here we need total ramp density, so we will take the 16 ramps here. Anyways, let me write the equation first. So this is the equation to calculate the free flow speed for a freeway. Okay, so like I mentioned, BFFS, the base free flow speed, will take it 75.4. Okay, factor for lane width, my lane width is 11, so my factor is 1.9. I have 2 feet lateral clearance on the right hand side. It's a 4-lane freeway. So 4-lane meaning there are 2 lanes in each direction. Whenever they mention the number of lanes with the freeway, they are always mentioning the total number of lanes. Okay, so 2 lanes in each direction and 2 feet clearance, so factor is 2.4. Then the ramp density, as I already mentioned, we will not look at the number of interchanges, we are looking for ramp density. So 16 divided by 6. Okay, so this is 63.8 miles per hour. Okay, so then next we'll be discussing the calculation and adjustment for capacity, inshallah.